Today's video will serve as an introduction of key concepts for the thermochemistry unit. The law of conservation of energy is very important to keep in mind throughout this unit. Remember that energy may change form, but it is never created or destroyed. If something gains energy, then it must take energy from its surroundings. Likewise, if something loses energy, then its surroundings will gain energy. For this reason, every form of energy on Earth has come from some other source. If you trace back far enough, all energy on Earth originated from the sun. In the case of your car, nuclear energy in the sun gets transferred to radiant energy, which becomes chemical energy, which becomes mechanical energy when your car runs. The sun's energy has been converted to chemical energy by plants through the process of photosynthesis. You would have learned about this process in science or biology and should have a general understanding of the reactants and products in this reaction. You should also remember the reactants and products of cellular respiration. It may be helpful to think of cellular respiration as being similar to the combustion of glucose. There is a significant difference between the two reactions, though. Liquid water is produced in cellular respiration, and water vapor is produced in combustion. There are two types of chemical changes in thermochemistry. Some reactions will result in a loss of energy or heat. These reactions are called exothermic. If you graph the potential energy throughout an exothermic reaction, you will see that the amount of energy of the entity decreases because energy is released. The opposite type of reaction is endothermic. In endothermic reactions, energy or heat is taken in. This results in an increase in potential energy that can be seen on a potential energy graph. In this example of an exothermic change, the change in potential energy of the chemical system equals the change in kinetic energy of the surroundings. This is consistent with the law of conservation of energy. To accurately study energy transfers, it is important to use isolated systems. Isolated systems do not allow matter or energy to move in or out. We will learn more about how this can be done in the coming lessons. Here are some other important terms that you may be familiar with from previous science courses. Kinetic energy has to do with motion. Chemical potential energy is the energy that is stored in chemical bonds. Thermal energy is the total kinetic energy of all of the particles of a system. Temperature is a measure of the average kinetic energy of the particles in a system. Heat is the transfer of thermal energy. It is important to understand the distinction between heat and temperature. Temperature is a measurement of the average kinetic energy of a substance, and heat is the total kinetic energy of a system. When there is an energy change in a chemical system between the reactants and the products, we will call that the enthalpy of reaction or the change in enthalpy. A good example to help you understand the distinction between heat and temperature is the hot cup of coffee versus the iceberg. Which one has more thermal energy? The iceberg. Put very roughly, thermal energy is related to the amount of something you have multiplied by the temperature. Let's assume the iceberg is at freezing, which is 273 degrees Kelvin. And the cup of coffee is at 75 degrees Celsius or 350 degrees Kelvin. Although the cup of coffee is warmer, The iceberg is thousands of times larger than a cup of coffee. The iceberg contains more thermal energy because the particles are moving, and it's much larger than the cup of coffee. Thanks for watching your first thermochemistry video. Please come to class prepared for the Check Your Understanding questions.